welcome to today's lesson. Today we're going to look at some of the other transformations that are possible with sine and cosine. And just to kind of review what we've seen before, what we've seen is if we have a function like this, good old sine of x, we can change a couple of things very easily. We can put a number in front of the entire function, which I will call a, and that is the effect of changing the amplitude, or how much the function oscillates up and down. By putting another number in here, and I'll just use b, that has the effect of changing the period, or the length of one cycle of the function. And that period would be changed by the reciprocal of b times what the normal period of that function is. And the regular period of sine is either 360 degrees or 2 pi in radian measure. What we're going to look at today is two other ways that we can change this particular function as well as the cosine function and how that would affect the graph. The first one I'm going to look at is quite easy. If you think back to every other standard function that we've looked at, and I'll just say y equals f of x, very simple function perhaps, and we want to maybe shift that function up or down, well, I'll just tack on some kind of a number, and I'm going to use d, because what we call this number in trigonometry kind of talk is the vertical displacement. So what we have here is the vertical displacement, which is how much we shift up or down. And you'll see with examples that, for example, if this said plus 7, the entire graph would get shifted up 7. If this said minus 3, it would pull the entire graph down 3 units. The other thing that I'm going to be looking at is called the phase shift. And phase shift is a fancy way of describing a shift to the right or left. Now, phase shift, when we looked at a regular function like y equals f of x, how did we move a function to the right or to the left? We did this to it. If this was our regular function, we simply tacked a number next to x with addition or subtraction. And I'm going to call that number minus p. Remember that in the phase shift, it can be a little bit confusing because we might see x minus 3, and yet it is a shift to positive 3. And a way to keep track of that is simply ask yourself, what value of x produces 0? And that's the value that you shift towards. So I always think to myself, equals 0, and that's where I want to phase shift. Okay, those are the only remaining changes. And what we're now going to do is have a look at some examples. Okay. The first example I'm going to look at, I think, will involve all of the possible transformations. And so what we want to do is graph the following. Y equals 1/2 times sine of 3x plus pi minus 1. So we have a little bit of everything happening in this example. It's important with these trigonometric functions like sine and cosine that we are able to identify what these four transformations are. So we'll start with amplitude. It's probably the easiest of them, and that's the number out front. The amplitude is 1/2. So what it means is from the middle of the graph, we're going to oscillate up a half and down a half. The next thing I think is probably the easiest, the period. And in this case, we have to do some factoring before we can identify the period. I guess it's really more the phase shift that the factoring affects, but it's really a good idea to do the following before you get into all these identifications. The 1/2 is fine, but what I need to do is take this 3 that's in front of the x and factor it within my set of brackets. Okay, so let me just show you what that looks like. This would become 3 times x, and where it's really going to have its most dramatic impact is the number that's tacked on to x. This would become plus pi over 3. And I don't really have room for my square brackets, so I'm going to have to clean that up a bit. There we go. And then the rounded bracket, minus 1. So now in this form, it's important because although the period would still have been the 3 in front of the x that's affecting it, it's the phase shift which comes up later which will have the most dramatic impact. So the period, well, I take the reciprocal of 3, so 1/3, times the normal period of sine, which is 2 pi. Now how do I know, just take a moment here, how do I know I shouldn't use 360 degrees? Why did I use 2 pi? Because up here there was a pi in the equation, and that's pretty much the indicator to me that we want to be working in radians. Okay? If I had seen something like 3x plus 90, and there would have been a little degree symbol, that would have told me, okay, then I'm going to work in degrees. But seeing something with a pi is very much the green light to work in radians. So the period here is going to be 2/3 pi. Okay. Next thing would be the vertical displacement. Now is nice and easy. The graph gets pulled down 1 unit, so -1. And the last thing is the phase shift. And this is the one that required the bit of factoring. Now we can clearly see that we want to phase shift this over to negative pi over 3. Okay, so I'm now ready to put the graph together. Now here's another tip when drawing the graphs. Don't stick to one type of x and y axis. It's better to be very flexible and say, okay, in this case, the amplitude is only 1/2. The vertical displacement is only going to pull me down by 1 unit. So don't make the y-axis go up 10 and down 10. You don't need it. Okay? The whole graph is going to be pulled down 1, and from this -1, it's going to oscillate only up and down by 1/2. So we could do something like this. We could say, okay, there's the y-axis. Why don't we make the x-axis this guy near the top of it? So I kind of adapted my axes a little bit. And since I'm going to be vertically displacing down to -1, and from -1 I'm going to oscillate up 1/2 and down 1/2, then probably this is more than sufficient to draw a reasonable graph. So this would be -1/2, and down here would be -1.5. Okay. I find it very helpful also, once I've identified the kind of framework of the graph, I draw some sort of guidelines in place, and that helps me to maintain a pretty reasonable, maybe a little bit more accurate graph. So this is going to be kind of the middle line of my graph, and then it's helpful to put in these little guidelines at the top and bottom. So I kind of know that my graph is framed in by the top and bottom dotted line, and that right here in the middle It's kind of the spine of the graph. Next thing I have to do is work out some kind of a scale. Well, I see that the period is only 2/3 pi. So I'm not going to go like pi 2, pi 3, pi 4, pi. I mean, that's silly. In order to do a couple of cycles here, I only need to go 2/3 pi and another 2/3 pi. So I need to go 4/3 pi. Well, that's just a little over pi. So maybe this will be pi over here. And that's probably more than enough to get a couple of cycles in. The other thing is that they're working in thirds here. And the phase shift is working in thirds. So it'd probably be very smart for me to break the scale up into thirds. So there'd be 1/3 pi, 2/3 pi, and then 3/3 pi is pi itself. Maybe I'll make that one a little bit bigger. And so 1/3 pi to the left would be about there. And maybe I'll throw in an extra third there. So now I've got a pretty good set of guidelines here. I'll just extend my dotted lines here a little bit, since I'm going to be phase shifting over here to negative pi by 3. Now, we're looking at sine. Sine starts at 0, and when the cycle is finished, sine ends at 0. Now, the cycle is 2/3 pi. And since each of these little markings now represents 1/3 pi, I know that the cycle ends 1/3, 2/3. This is where it'll end. And halfway through, I'm also at 0. Halfway in between, I should be at my maximum. And halfway in between these 2 points, I'm at my minimum. So there it is. I've got one nice little cycle all set up. And if I just copy this cycle now, and go one more cycle, okay, so I'm going to mark my zeros, and then my maximum, and my minimum, and I've got 2 cycles. And there it is. That's all there is to it. The real thinking comes when you figure out all these 4 things, and then trying to figure out a reasonable scale so that your graph isn't difficult to draw. Once you've got that done, it's not bad. So that's the end of that example. Let's do one other observation here, which is very important, and that is, what's the range of this particular graph? The domain, of course, is all x values, but what about the range? What is the limits of the y values? Well, not too bad. When you look at the graph, we can simply say, well, y is kind of between negative 1.5, that's our smallest value, and our largest value is negative 1/2. So if we cared, if we were interested, that would be the range for the y. Well, I feel we need to do one more example, and then I think we've kind of got the idea of graphing and the 4 main transformations kind of cased. So let's do one last example and call it a day. Just clean up the old board here and see what we can do as far as a good example. Okay, I think in this example I'm going to use cosine, and I'm going to try and graph the following. I'm going to graph y equals negative 3 cosine, and put 1/3 out front, and x minus pi plus 2. So again, we got the complete package happening here. I'm going to try and identify the amplitude and the period. Well, let's start with the amplitude. I see it says negative 3. Does that mean the amplitude is negative 3? No. The amplitude is always positive. And so amplitude is a length. And so even though it looks very tempting to think of it as negative 3, the amplitude is in fact positive 3. The period, well, that'll be affected by this number's reciprocal. So instead of 1/3, it'll be 3. times the normal period of cosine, which is 2 pi. So we have 6 pi. So very, very much stretched out. Vertical displacement. Well, what do we have here? A plus 2. Okay, so the graph gets shifted up 2. And finally, the phase shift. Well, it's already in a nicely factored form, so no problem here. So we identify that it will shift to positive pi. So we're all set. Okay, a little mental note. Amplitude is 3, and we vertically displace up 2. So I certainly don't want the graph to be only going up 1 and down 1 or something like that. So I've got to be thinking a little bit ahead. So again, amplitude is 3, vertically displacing up 2. So maybe I'll make this the x-axis. And vertically displaced up 2 might be 1, 2. And then we have to go up 1, 2, 3. So we will achieve a maximum value of 5. And at 2 here is where we want the kind of middle or spine of the graph. And we will be oscillating from that point down 3 as well. So down 1, 2, 3. So at negative 1. So we'll just put some guidelines in here. And that nicely frames our graph. And now I see that one period is 6 pi, and I'm phase shifting pi to the right. So I certainly don't want to say, well, let's make this pi or something like that. I wouldn't get a full cycle. And it's always nice to get 2 cycles. So what I'm going to do is kind of think backwards here and say, well, why don't we make this 12 pi? That might be too small for you to see, but this is 12 pi. And so halfway between that is 6 pi. And I'll mark some more spots. Halfway between that would be 3 pi. Halfway between this would be 9 pi. And then I can just break this up into thirds again. So sort of, and I won't write the numbers, but 1 pi, 2 pi, 3 pi, 4, 5, 6 pi, 7, 8, 9, 10, 11, 12, and throw in 13 for good measure. The next thing is, well, the phase shift is at positive pi, so we're going to be starting this thing somewhere along here. I put a little vertical line through that kind of starting point, and sometimes it's very helpful to also put a little vertical line at the end of the cycle. The full period is 6 pi. We're starting a pi to the right, so at 7 pi we should have finished the cycle. So that's going to be the complete graph drawn. And since I probably should do 2 cycles, from 7 pi I'll go another 6 pi, taking me to 13 pi. Okay, so this kind of frames in my graph. Now all I have to think is, well, this is cosine with a negative in front. Now what that negative does is it simply reflects the graph. The graph gets flipped over. So normally cosine starts at its maximum. In this case it gets reflected. So it starts at its maximum flipped over. So in this case it's minimum. Then it oscillates up. Well, probably the easiest thing, since we've got all these different strange markings, is to think, in this case, because it's all been flipped over, it's going to go up to its maximum and then back down from whence it came. So these points are kind of marking the start and finish of each cycle. Halfway between that, which would have been over 1, 2, 3, I should be at my maximum height. Same thing here, 1, 2, 3, and I'll be at my maximum height. And now I just want to be halfway between this minimum and this maximum, which is kind of awkward because I didn't really mark them in. But what it is, I have 1, 2, 3 units, so I want to go 1.5 units, and that will put me at 0. So it's a little bit awkward with my scale, but quite doable. So from here I want to go 1.5 units, and that puts me at 0. Same thing from here. It always repeats. So 1.5 over puts me at 0. And from here over 1.5 puts me at 0. So there it is. Those are the important nodes or junctions for the graph. And so it's going to look like this. Whoops. Not very well drawn at all. Okay, I didn't really get a good start on it. Let me see if I can fix that up a little bit. It kind of should have come up like that. All right, so I'm not an artist, but at least I've got an accurate graph. And that, ladies and gentlemen, are the transformations that we do to sine and or cosine. We'll catch you later.